So to piggyback on that last problem we did, we're looking here at these rules. So if we have a to the m times a to the n, we add our exponents. But if n is equal to 0, what that means is we have a to the m times a to the 0, which is just a to the m. So we're looking at what are we doing here? We can divide both sides of the equation by a to the m, and we discover that a to the 0 is equal to 1. If n is a negative integer, and we multiply a to the negative n times a to the n, we end up with a to the 0, which is 1. This is an identity. So what it shows us is that a to the negative n is a reciprocal of a to the n, which is why we end up with this rule. So you don't have to write these down. They're already in your notes, but highlight them, put gigantic stars next to them, do what you need to do. Anything to the 0 power is equal to 1. Anything to a negative power, you do 1 over the positive power. So we will start with expressing in simplest form with no negative exponents. So we have 458 times 10 to the negative 4th, so that's 1 over 10 to the 4th power. That means a 1 with 4 zeros. And that ends up being 0.0458. This is called scientific notation. We will not spend time in this class on scientific notation, but you will see it a lot in your science classes. Okay, taking a look at the next one. These get quite a bit more complicated, although the same rules will apply. 6 to the negative 1 means that 6 goes in the denominator. X to the negative 2 means that x squared goes in the denominator. Z cubed means that z stays in the numerator. 5 to the 0 means that that's just 1. Z to the negative 2 means that z squared goes in the numerator. So anytime you see a negative exponent, you move it to the other part of the fraction. So here we've got negative exponents that all had to move up, which means that I missed one. I missed x to the negative 1. Becomes x to the first. So I have here x, z to the 5th, over 6x squared. Now when we start canceling, you'll see this happen a lot. I will cross out this x, and I will cross out this 2. So that will tell me that this is now z to the 5th in the numerator and 6x in the denominator. Trying another one. 4m to the negative 2 over n. That becomes 4 over m squared n. Then, with this next one, because I'm raising this whole fraction to the negative 1 power, I can actually just take the reciprocal. 3n squared over m cubed. So that's not 4. That will be 4 times 3, which is 12. 12n squared over m to the 5th power, and I got that by multiplying m squared times m cubed times n. So if I look in the numerator and denominator, there's an m in the denominator but not the numerator. There's n squared here, n here. So this will cancel, and I will get 12n over m to the 5th power. With this, we're actually going backwards. We're going to express this without using fractions. So the first one would be 3 times 1 over 100,000. So that becomes 3 times 1 over 10 to the 5th power. I know it's the 5th power because there are 5 zeros. And because I can't use fractions, 3 times 10 to the negative 5th. Next one, 2a. Now in the denominator, I've got t to the negative 3, b to the negative 1. On this last one, the first thing that I will do is simplify, then I will remove all the fractions. So if I have 8x squared y over xy cubed, this will become x to the first. That will become y squared. And I have the numerator is 8x. The denominator is y squared. So I will have 8x y to the negative 2 power.